Welcome back. This time, you'll find the inverse of each function. We have here 4 functions. Shall we start? Let me share my whiteboard. Okay, now, in example number 1, we have f of x equals 1 minus 2x. The first step is we change f of x into y. So it becomes y equals 1 minus 2x. Next, we interchange x and y. So y becomes x while x becomes y. And we change, since we do the interchanging, we write it as y to negative 1. It means that an interchange already happened. Then we solve for the value of, we write y to negative 1 in terms of x. So we transfer other values to the other side. Or we could also transfer this one and then transfer x. So for example, we have 2y to the negative 1 equals 1 minus x. We need to divide both sides by 2. So y to the negative 1, or we say the inverse of y, is equal to 1 minus x over 2. In the final answer, we need to change y to negative 1 to f to the negative 1. It means it is the inverse now. So 1 minus x over 2. This is now the inverse function of the original one. Now let's have example number 2. For example number 2, we have f of x equals 3x squared. Again, we change f of x to y. Then we interchange x and y. So y becomes x and x becomes y. But this time, let's have it y to negative 1 and there's a squared outside. Then, since we need to have just y to negative 1 left, we need to divide both sides by 3. So we now have x over 3 equals y to negative 1 squared. To eliminate the square, we need to extract the square roots of both sides. So we now have y to the negative 1 equals square root of x over 3. And the last answer, we need to change y to negative 1 to f to the negative 1 of x equals square root of x over 3. We apply the symmetric property, it will become f to the negative 1 of x equals square root of x over 3. Here's the answer for number 2. Now, let's go to number 3, or letter C. For letter C, we have f of x equals 2x plus 5. First, we change f of x to y. Then, we interchange y and x. So this becomes x, while x becomes y. Since we do the interchange, it will be y to negative 1. Then we transfer the rest to the other side. So it becomes x minus 5 plus 2y to negative 1. Or if we do symmetric property, it is 2y to negative 1 plus x minus 5. Divide all by 2, the numerical coefficient of y to negative 1. We have y to negative 1 equals x minus 5 over 2. We need to change y to negative 1 to f to the negative 1 of x as a notation equals x minus 5 over 2. Here is the answer. Now let's have the last example. Example letter D. We have f of x equals x minus 10 over 3. Again, we change f of x to y. Then, we will interchange y and x. So y becomes x, and x becomes y to negative 1. Then we need to solve for y to negative 1. So we do cross multiplication. It becomes 3x equals y to negative 1 minus 10. Then we do transposition. 3x plus 10 equals y to negative 1. Then we change the sign or the notation for y to negative 1 to f the negative 1 of x equals 3x plus 10. When we apply the symmetric property of equality, we have f to negative 1 of x equals 3x plus 10. Here's the answer for the inverse of f of x equals x minus 10 all over 3.